Hi everyone, and welcome back to this series of solving PEO exam ELEC A5, the electronics course. This is a diode question, but in this question here you have an AC input. In the previous diode question, we have only DC bias, so we have to figure out which diode is forward bias, which diode is reverse bias, and solve the question. Then you have to check the conditions to make sure that the diode was correctly assumed. Now here it's a different question. The diode is assumed ideal and has a forward voltage 0.7. So if the diode is conducting, it will have a 0.7 voltage drop. Now we need to sketch the output voltage. That's what we want. To be able to do that, we need to know if the diode is forward bias or if the diode is reverse bias. Now, sometimes we have DC battery, like in these questions. Sometimes there's nothing, just the AC. So we need to understand the behavior of the diode under these conditions and see and then decide. Just as a refresh our memories, this is our diode here. Okay, so we will have the anode and then we have the cathode. Now for the diode to be forward bias, the diode has to have a potential at A more than at K or at the cathode by certain voltage. Like in this question, it has to be 0.7. So the voltage here has to be more than here by 0.7. If this is the case, then the diode will be forward bias, and it will be modeled as a battery with the plus at the anode, negative at the cathode. But if the voltage is less than 0.7 or it's negative voltage, then the diode will be reverse bias and it will be modeled as an open circuit. So the whole idea here is trying to figure out if the diode is actually forward bias or if it is reverse bias, model it, and then you move on. So let's see the first part here. So we have the diode here, we have the AC. Now, before we start incorporating the AC input, it is a better idea trying to know without the input, what will be the diode? Will be forward or will be reverse bias? So here the diode will be forward bias. So if there is no input, there is no AC input, opposing or actually going with the 3-volt battery, then the diode will be actually forward bias. So this is a good information to know. Now let's see what will happen when the voltage is in the positive polarity. Now, if the voltage exceed, now the voltage, as I mentioned here, it's forward bias. Now, for the diode to be actually reverse bias, this voltage has to exceed this voltage, the 3 voltage, minus the voltage that you have across the diode, which is the 0.7. Now, this voltage polarity is opposing the 3-volt battery, so it's a total of 2.3. So when my voltage here exceed the 2.3, then the voltage here will stop the battery from forward biasing the diode, and the diode will be reverse biased. Okay, so the 2.3 here is actually very, very important. This is the 2.3 volt. So again, if the diode is more, if the voltage is more than this, meaning between this point and that point, we have more voltage here than the battery that would make the diode forward bias. So then we'll have a reverse bias. Reverse bias means it's an open circuit, meaning that your output equal to 0. So the output here will be equal to 0. What will happen if the voltage is actually less than 2.3? If it is less than 2.3, then the diode will be forward bias because this battery now will have enough voltage to forward bias the diode. And the output now, you need to find using a KVL. So here, if you say take KVL minus VN plus 3 minus 0.7 plus V out equal to 0. So your V out would equal to Vn minus 2.3. That will be your output. Okay? So if Vn, for instance, is equal to 0, the starting here, then this will be minus 2.3. So this is here minus 2.3. So it will follow the sinusoidal here. And the same thing when the comes here until we reach to the negative. We have this point. Now, what will happen in the negative cycle? In the negative cycle, your input basically will be equal to this. This is your V input. Now, the polarity of your Vn is in the same direction as the 3 volt. Remember, we said that the diode without any input is forward bias. Now, I am adding more voltage with the same polarity. So the diode during the negative cycle will be always forward bias. And again, let's apply KVL here. So we'll have plus Vn plus 3 volt minus 0.7 plus V out equal to 0. So from this, your V out will equal to minus Vn minus 2.3. So you will have the minus 2.3 volt. So the voltage, the output will be less by the input by 2.3. So here, this will be 2.3 volt. When it reaches here, goes back to 0 and continue like this. So this is how we approach such question. Let's go to part B. In part B, it's exactly the same as A. The only thing I have done, I just flipped the pattern, the polarity of the pattern. Let's see what will happen. So let's see what is the default here. Now the default without an input, that the diode will be reverse bias. This is my anode, this is my cathode. So the voltage at the cathode is higher. So it will be always reverse bias. So it will be always open circuit. Okay? So good to know that. Now let's see what will happen in the positive cycle. The positive cycle, basically, your voltage will be the same polarity as the 3 volt. It means that if without the input, without the AC input, the diode is reverse bias, open circuit. Now, when I am adding even more to the 3, goes from 0 to 13, it will be even more reverse bias. Okay, so the diode during the positive cycle always reverse bias, will be always an open circuit. So from here to here will be short circuit. From here to here, and from here to here, always a short circuit. Okay. Because this is an open circuit, this would be like voltage equal to 0, not short circuit actually, but V equal to 0. Now let's see the negative cycle. What will happen during the negative cycle? The negative cycle, the voltage polarity will be different here. Now the polarity, the positive polarity here will be, or the negative polarity, as this is now has been reversed, this becomes the positive, this is the negative. Now the anode will start to get higher voltage than the cathode, but still you have to overcome this, and also you have to overcome the 0.7. So when the voltage exceeded the 3.7 here, then the diode will become equal to, will be forward bias. Okay, so when the voltage is less than minus 3.7, because this is basically this is a negative cycle. So this is the 3.7 here. This is the minus 3.7. So when the voltage goes below this voltage level, okay, then the diode will be forward bias. So this will be until here. This will be also 0. But during this, actually the diode will be now will start to be forward bias, having 0.7 volt. Now, again, applying KVL, your output will be equal to minus Vn plus 3.75 volts. So you will have here, your output will be something like this, with 3.7 here, difference, 3.7 volt here. Or otherwise, it will be 0. So only when the voltage drop below 3.7, okay, okay, only after that, the diode will be, only at that period where the diode will be actually forward bias. Let's see the third question. Now, in the third question here, if you remove the supply, the diode will not be conducting. because there is no DC supply here. Okay. So now let's see what will happen if I add the positive. Now, when you add the positive polarity here, plus minus, so the diode will be conducting only when the voltage exceeds the 0.7 volt. If it is less than the 0.7, so here it is less than 0.7, it is less than 0.7 volt, okay, your voltage will be actually what? Your voltage, your diode will be open circuit. Now, if the diode is an open circuit, your output voltage, this is your VN, 1 kilo in series with 1 kilo, your V out using voltage division, VN times 1 kilo divided by 1 kilo plus 1 kilo, or it is equal to half VN. So your V output will be equal to half VN at that period, okay? Now, when the voltage exceeds the 0.7, this diode will be conducting and you will have a positive negative polarity here. So V out will be always 0.7, constant voltage, until it reaches here. And then again, it will go down. Now, in the negative cycle, the diode will be always, this is the positive cycle, in the negative cycle, the diode will be always open circuit. And your output, V out, will be always 1/2 VN. So during the negative cycle, the diode will be actually always half. So this will be something like this. Yes. And then you move on. 0.7. And you keep doing this. So that here, this will be -5. And the peak of the input is minus. Okay. Now, let's see question D. In question D and E, I will not solve it. Okay, so what I want from you to come here and pause it yourself. Okay, think about it. Try to draw the circuit, the waveform, and then this is your output. So the blue is this is the output of your circuit. This is the second question. Same thing. Please pause it. Try to think about it. Try to solve it. And then this will be the results. This is the explanation, and this will be the results. So with this, we know now how to handle a question where you have a diode and you are asked basically to draw the waveform.